me get this up on the screen and then we'll get going. Okay, so change in tandem. It sounds like it's going to be intimidating. It's not, okay? And we're only doing one lesson today. So you're only doing one today. When you come back on Monday, we'll do 2 lessons. But today we're just going to kind of ease our way in with 1. Okay, it's technically one. It's more than one lesson, but it's like 3 different concepts: 1, 1, 1, 2, 1, 3, kind of combined into one set of notes. Okay, so we have some fill in the blank at the top of our notes that we're going to start with, and they're using a lot of fancy math verbiage. We're going to break it down into like layman's terms where it's easier to understand. Okay, so first sentence. A function, that's our first fill in the blank, a function is a mathematical relation that maps a set of input values to a set of output values such that each input value is mapped to exactly one output value. That's confusing. That's a lot of words that don't really make a whole lot of sense. Okay, so let's break it down a little bit. So first of all, a relation is just a bunch of XY points. Okay, that's what makes a relation a relation. It's just a bunch of XY points. Okay. Input values, they're never gonna say in this class X's and Y's. Okay, they're gonna say input values and output values. So we need to get used to changing that in our vocabulary. Okay, inputs, if you are given an equation and you're making like an XY chart, what are you inputting? X's or Y's? Like, what are you plugging in for? If you have a Y equals MX plus B and you're plugging in to find, like, to fill out an XY chart. The X's, right? So remember that. Inputting, you are usually plugging in for X, correct? So input value is referring to your X's. Output values is what you get out when you plug in those X's. So output values are your Y's. Okay, so that each input value, that's an X, is mapped to exactly one Y. So reading that again, if we just change those words to inputs and to X's and Y's instead of input values, output values, it says a function is a bunch of XY points that maps my X's to a set of Y's such that each X is matched with only one Y. The way that I taught you in Algebra 2, if you were with me in Algebra 2, was a function can't have repeating X's. Okay, so if I had a list of points, I couldn't have any repeating X's. If I had repeating X's, it wasn't a function, right? You also used the vertical line test to test this in Algebra 2. And the reason that the vertical line test works is because, for example, if I'm just zooming in and drawing here, if I was to graph something like a sideways parabola and I try to do the vertical line test on it, it fails because of these 2 points, which are going to have the same X's, right? If this is like 1, 2, then this is 1, negative 2. They share the same X. If 2 points are vertically on top of each other, they're going to have the same X value, correct? Okay, that's why vertical line test works. Because if that happens, it's not a function, because it shares 2 same X's. So that's what that sentence is talking about. It's saying that every X has to be matched with exactly only one Y. Okay? That's what makes a function a function. So that's the big, fancy mathematical definition of what a function is. But the way that we learned it, the layman's terms, the easier way to understand it, just you can't have repeating X's. Okay, so a function will never have repeating X's. Okay, next it says you may have used the vertical line test, blah, blah, blah. Okay, set of input values. Input, remember we're talking about input means X's, is called what? Do we call input, is X's our domain or range? Domain. X's are your domain. And that's represented by the independent variable. That's another word that they're going to use to describe X's. So like I said, they're never just going to say, take your X's or use your Y's. They're not going to say X's and Y's. They're either going to say input value or independent variable. How do you remember which one's independent and dependent? Because my Y, if I have an equation like Y equals 7x plus 4 and I'm filling out an XY chart, I'm plugging in the X's to get the Y's that match them, correct? So my X is independent, my Y depends on what I have plugged in for X, okay? So what I plug in for X, that's independent. I can plug in whatever I want, but what I get for Y depends on what I plugged in for X. So X is independent. Output, which represents our Y's, is called our range. Y's are our range. And that is our dependent variable. Okay, so this top part is basically just getting you used to that different vocabulary, right? This is AP now, right? So they're gonna expect you to like talk in fancier terms than, you know, your lower level classes. When I taught you guys domain and range, the shortcut that I taught you to remember domain and range, like which one went with X, which one went with Y, because, you know, I never remember. I can't remember. Like, I have memory issues. I'm worried for when I get old because it's already bad and I'm not quite old yet, right? But the way that I taught you guys was that X comes before Y in the alphabet and D comes before R in the alphabet. So X goes with domain, Y goes with range. Okay, just a little side note in case that helps anybody. All right, so what the heck are we gonna do with this information? What are they gonna ask us? What are they gonna ask us for? Okay, well, sometimes they might just, like some of that is just gonna be a part of the questions that they ask us, all right? So we're gonna start off with just looking at these couple of sets of given info. Another thing that College Board is gonna do really well as we go throughout this class is they're going to ask you questions with a whole bunch of different types of given information. Right, so maybe they give you a chart, maybe they give you a sentence, maybe they give you a graph. Like, they're gonna ask you all kinds of things like with different sets of starting info, okay? So A says, we're sketching the graph from -4 to +4. So this whole like -4 to +4 means we're only graphing from here to here, -4 to +4, okay? That's all that means. For the function with these rules below. So A, the function f, meaning like your y, right? Because when we write equations, we write f of x equals, and we always talk about how f of x is the same as y, right? Okay, so that's meaning our function, or our y, halves each input value and then adds 1. So remember, input, what's input, x or y? X. So it's gonna half each x and then add 1. Function f, remember that's the same as y. So if I was to like write an equation for this, that would be y, which is f, is half of each input value, which is gonna be a half x or x over 2, whichever one you wanna write, and then we're adding 1. So an equation that could go with that would be y equals a half x plus 1. Excuse me. So now we're supposed to graph that from -4 to +4, from x equals -4 to x equals +4. What kind of shape is this going to make when I graph it? A line. That's linear, right? That's an mx plus b. So that's a line. How many points do I need to make a line? Only 2, right? So since I'm starting at -4 and I'm going to +4, let's use those 2, all right? So if I was to make myself a tiny little XY chart, I need to go with my starting point and my ending point. So when x is -4 and when x is +4. And anytime ever in math, ever, no matter what class you're in, if you don't know what a graph looks like, make an XY chart and grab a few points. How do we get the y's that match x's? Plug them in, right? So plug in -4, that's half of -4, which is -2, plus 1 is -1, right? So that means I'm starting at the point -4, -1. And then when I plug in 4, that's going to be half of 4, which is 2. 2 plus 1 is 3. So that gives me the point 4, 3. And I'm going to connect those. And I'm not going to draw arrows because I'm only graphing it from -4 to +4. So there is the segment of that line whose y's are half of the x and then added 1. Okay? So do you already see how like they're challenging you to think a little bit different than how you've normally thought? Like if I gave you, hey, graph half x plus 1, like y'all can do that in your sleep. You've been doing that since algebra 1, right? But now it's not saying, hey, graph half x plus 1. It's saying graph the function whose f halves each input value and then adds 1. Like it's just a higher level of asking you to think, right? Okay. All right, B. Now they give you x, y points. This is already an x, y chart. No equation, no sentence, just, what, 5 different points? Okay, literally all we know about this function, function g, is these 5 points. So we're gonna plot these 5 points. We've got -4, -1. Notice that it also has, well, never mind, I'll talk about that in a second. -1, 2 is up here. 0, 3, 2, 3, and 4, 1. Do we know anything about what's going on like in between -4 and -1? No. We don't know anything about in between these two, or anything in between these two, or anything. We don't know anything except for these 5 points. That's it. That's all we know. So that's all we can graph. We can't connect them, so we don't know that that's how they connect. Like they could connect like straight lines, but what if they didn't? What if they connected like this? Right? Like we don't know. We don't have enough information to be able to connect them. So all we know is these 5 points, and then that's all we can graph. Okay? All right, now let's talk about graphical behavior. Increasing and decreasing. Increasing and decreasing is pretty easy for you to look at a graph and see if something is increasing or decreasing. So as you're moving from left to right, is your graph going like getting higher or is it getting lower, right? So we can look at this and we can say as my graph is moving from left to right, my graph is increasing. It is getting higher as we move from left to right, correct? And decreasing as we move from left to right, this one is getting lower, it's getting smaller. The technical way to talk about that though, with like input values, output values, all of that kind of stuff, as the input values, which is our x's, right? So again, you have to think, okay, that's x's. Like even me, after doing this for so many years, I still have to think that means x's, right? So like, as my x's increase, meaning moving from left to right, so as my x's go -3 and -2 and -1 and 0, 1, 2, 3, as they're getting bigger, my y values are increasing. So as I'm moving this direction, my y values are going up. My y's are going from -1 to 0 to 1 to 2 to 3. And my y values are also increasing. And decreasing as my x's increase, my y values decrease. Makes pretty logical sense, right? Okay, now let's talk about concave up and concave down. Concave up is when something looks like an opening up parabola. Okay, concave down is when it looks like an opening down parabola. The graphs that you see here, like this is always concave up, this is always concave down. But a lot of the graphs that you're gonna work with are gonna kind of look like roller coasters, right? Where there's like parts of it that are concave up, but then it turns to concave down. Then it turns back to concave up, okay? So let's take a look at these two definitions are pretty important, and they're going to come back up over and over and over and over. So star this, highlight it, circle it, like whatever you need to do. Make note that this information right here, the concave up, concave down, is a big deal. They're going to talk about this a lot. For something to be concave up, the rate of change is increasing. Now let's talk about that. In math, when they say rate of change is the same thing as like slope. Okay? So if we're looking at this concave up graph, you are used to only lines having a slope, correct? Lines are the only thing that have a constant slope. Like no matter where I go on my line, the slope is the same, right? So like no matter where I go up here on this graph that we did earlier, the slope is a half. Doesn't matter which 2 points I pick. I go here, I go, up 1 over 2, and I'm at that point. I go up 1 over 2 again, and I'm here. Or I could have gone up, what is that? 4, so up 4 and over 8, right? But 4 over 8 is still a half, right? So no matter what on a line, the slope is always the same no matter what 2 points you pick. It's a constant slope. Lines are the only thing that have a constant slope, right? So if we're talking about this opening up parabola, how can it possibly be talking about its rate of change or its slope? It's not a line. You need to imagine that every single little tiny point has its own slope. So think about like a bunch of tiny little lines, right? Like this. Like if I were to draw a bunch of tiny little lines, right? All these that I just drew on the left-hand side of the graph, what can you tell me? You're not going to know that like what the slope is, like 5 or half or 2/3. But what can you tell me about all of these slopes that slant this direction?
It's like less steep.
They're, okay, they're getting less steep. That's one thing.
Increasing. No.
Yes, but I'm looking for positive, negative. Which one?
Oh, it's negative.
They're all negative because they're all slanting in this direction, right? And a line that slants in this direction is a negative slope, correct? Yes? It's like I either went up and left or down and right, but anything that slants this way has a negative slope. And then you see that it like starts out pretty steep, but then every tiny little line I drew gets a little less steep, right? Until all of a sudden it gets horizontal, completely horizontal. Yes? The steeper your slope, the bigger the number, right? So like something with a slope of negative, or with a slope of 7 is steeper than something with a slope of 2, right? So this is going to maybe a slope of like, let's just pretend, I'm totally making this up, like -9. Then maybe this has a slope of -8, and then this has a slope of -7, so forth and so on. So my slopes are increasing because -9 to -8 to -7 to -6 all the way to 0 is getting bigger, correct? And then after 0, look what starts happening. If I were to draw a bunch of little lines going this direction, what are the slopes now? They're still increasing, but what happened from this side of the graph to this side of the graph? They're positive now. So now we went from negative, 9-ish to -7 to -6 to -3 to -2 to then 0. Horizontal lines have a slope of 0, right? You learned that in Algebra 2. Then +1, +2, +3, +4, +5, +6, it's increasing as we move from left to right. The slopes are increasing. Does that make logical sense? Can we see that? Okay. So then, if you come over to concave down, anything that is concave down, your rate of change, i.e. your slopes, are decreasing, meaning they're starting out positive, but then they're going to get smaller and become negative. So look at your graph. Excuse me. I'm positive, pretty steep, right? Like, so a pretty high number positive, pretty positive high number. And I'm still positive, but not as steep. Still positive, not as steep, getting less steep, but still positive. And then all of a sudden I get to horizontal, which is 0, right? So this is positive slopes over here, then a slope of 0 on top, and then all of a sudden my slopes become negative, right? So this side was negative slopes, then a 0, then positive slopes. So it was increasing as we move from left to right. But now we start off big, get smaller, less, more horizontal means a smaller slope. Then finally a slope of 0, and then to negative slopes. So now we have positives, then 0, then negatives. So for something to be concave down, your slopes are going to be decreasing. Okay, so slopes increasing, concave up, slopes decreasing, that's concave down. And that's another verbiage that they're going to switch on you a lot. Hardly ever going to say slope, they're going to say rate of change. And rate of change is the same thing as slope. Okay? How many are we going up? How many are we going over? That's a rate of change. All right. The notes are pretty short today, but we're going to do an activity as well. So we're at second page of notes. All right, so here's a funky looking graph, right? Part of it is linear, like we got some lines, but we also have some parabolic sections. Like we've got this funky shape. Nobody needs to know the equation of this shape. They're not going to ask you to draw it or like come up with an equation. They're just going to ask you about which parts, excuse me, are increasing, decreasing, concave up, concave down, things of that nature. Okay? So graph of h of x is shown above. Use the graph to find the intervals, open intervals. Let's talk about that for a second, okay? When we talk about where things are increasing or decreasing or concave up and concave down, they're gonna ask you to write that in interval notation, intervals, okay? Intervals are the same as like inequalities. So if I wanna say x is greater than 2, I'm not gonna write x is greater than 2 anymore. I'm gonna write that as an interval, which is gonna look like this, 2 to infinity. Okay, it's not an xy point, even though it looks like an xy point, it's an interval. For intervals, you use parentheses when there's no equals to, like if it's an open circle, and you use a bracket if it's an equal to or a closed circle. So if I were to say x is greater than, or let's say less than, because I did greater than last time. Let's say less than or equal to 7. Then my interval would be negative infinity to 7 with a bracket around 7. So x's that are less than 7, think about what that looks like on a number line. Like here's 7, and we're going all the x's that are less than 7, right? So that bracket is from negative infinity, which is never going to have a bracket because you're never going to reach it, right? So we're never going to touch it, we're never going to reach it. It has to be a parentheses because it's not going to have an equal to. All the way up to 7, and we're going to put a bracket around 7 because we are including 7. So like closed circles are going to be brackets. Open circles are parentheses. Okay, so what if I had like one where it's in between, like negative 3 is less than x is less than or equal to 2. You know those double inequalities that you had in Algebra 2? You had ands and you had ors. This was an and because it has to be both. Bigger than negative 3 and at the same time less than or equal to 2. Well, the way that we would write that would be negative 3, comma, 2 with a bracket. Okay? So this is what they're talking about when they're talking about interval notation. As you get older, as you get into your upper level classes, you're gonna see less and less of like greater thans and less thans, and you're gonna see more and more of the interval notations. So what it's confusing sometimes when it looks like if it was this, but this was a parentheses, it would look like the point negative 3, 2, right? So how do you know if they're talking about the point or they're talking about the interval? the context of the problem, right? So if you read the problem and it's like, on the point, -3, 2, well then they're talking about the point. But if they're saying, on the, open interval, -3, 2, well, then they're talking about the interval. So like you have to like read the question, take into account the context of the question, and decide, whether they're talking about the point or the interval. It's not hard to know which one it is, okay? One will make sense, the other won't, all right? Okay, so side note on that, let me erase that. All right, so now, looking at this graph, part A, we're supposed to figure out where this graph is increasing. Okay, so just looking at the graph, I'm just gonna highlight the little sections that are increasing. Yes? So if we start over here at -4 on the left-hand side, what do we start off doing? Decreasing. Until here, right? And then here we start increasing, correct? Until here. So we're talking about this section right here, that's increasing. But then right after that it starts decreasing again, yes? And what about when it hits this little like hitch in the graph? Still decreasing until down here where we begin increasing again. So there's two sections of this graph where we're increasing, and we're gonna write these sections as intervals, okay? When you write intervals for like increasing, decreasing, you don't use brackets. Everything is just like parentheses, because technically at that actual point where it switches from increasing to decreasing or vice versa, it's not doing either. Okay, so we don't include it. So this one, and we're looking at x's. Don't get confused and use your y's, because you're thinking, oh, it's going up and it's going down, and very easily your eye will go to the y-axis. Okay, you're not using the y-axis. I'm saying what x's is it increasing to? So we need to think -2 to 0. Are you following me on that? Okay, so that's -2 to 0 with parentheses around each, so it looks like the point -2, 0. And again, x's, so we're looking from 4 all the way over here to 7. So -2 to 0 and 4 to 7. Right? So what I'm saying is that the number one mistake that kids will make is they will look at this section here, and they'll look and they'll see this section, and that's right, they know it's that section, but they'll say, oh, it's 1 to 3. Like, don't look at your y's, okay? Intervals are x's, from x equals what to x equals what. Okay, everybody okay? All right, next is, where is it decreasing? Well, you guys already answered this. It was this section and then this whole section here, yes? So that is -4 to -2 and 0 to 4. Okay, next, back to the graph. Where is it concave up? Meaning, where is it like opening up parabola? Where is it, where are my slopes? If I were to draw a bunch of tiny little slopes, where are those slopes increasing? Because concave up means my slopes are increasing, right? Are my slopes positive or negative right here? They're always negative. They're not increasing or decreasing. They're constant, right? So a line isn't concave up or concave down because my slope is the same everywhere on a line. It's the same, it's the same, it's the same, it's the same, it's the same. It's not increasing or decreasing. So it doesn't have concavity, okay? This section, concave down. It's easier to think, where does it look like an opening up or an opening down parabola, than it is to think about all the tiny little slopes. Okay, me showing you all the tiny little slopes was just explaining to you why. Okay, because they're going to use verbiage like, where are the rates of change positive? Well, that means concave up. Okay, So this, what are we looking for? Up. So the first section doesn't have a concavity because it's a line. The next little section is like an opening down parabola, so that's concave down. This section here is our concave up section. So that goes from x equals 2 to x equals 7. So parentheses 2, comma 7 with the parentheses at the end. Okay, then they're gonna ask us to combine. Where are we both increasing and concave down? Okay, some of you can look at that, see it, and immediately write down your answer. That's great. Some of you can't, and that's okay too. So if you're like me and I maybe can see it, but I also want to double check it because I'm OCD like that, right? I'm going to mark the sections that are one with one color, and I'm going to mark the sections that are the other with another color, and then I'm going to find where they're overlapping. That's how my brain works, okay? So if I'm going to do increasing, I'm increasing here, and I'm increasing here, right? Everything else is decreasing. Great. Then I'm going to change the color of my pen, maybe, or just use a different pen. And then I'm going to say, where is it concave down? It's concave down here. And that's it. So that middle section where it looks like an upside down parabola. My overlapping section is my answer. So here, from -2 to 0. From x equals a -2 to x equals 0. We'll do the same thing for E. We're looking for decreasing and concave up. This is why I like the iPad, because I can draw on it and erase it and draw on it and erase it. But, you know, I also have a computer. I'm lucky enough to have both. So, okay, decreasing, concave up. Decreasing, this is decreasing, and this whole section here is decreasing, right? Concave up is here. This whole last section is concave up. Where is that overlapping? Just this piece right here, which is from x equals 2 to x equals 4. Last thing on your notes before you're going to go to your activity is they're going to ask you to draw the graph based on this given information. Okay, so our graph is increasing on the intervals -4 to 1 and 5 to 7. So this is what I'm talking about. Like, you can read that and you realize those aren't points, those are intervals, right? So that means from x equals -4 all the way over to x equals 1, my graph is increasing. So that means it's going to be getting higher from left to right. And again from 5 to 7. It's decreasing in the middle from 1 to 5. So we're increasing, then we're going to be decreasing, then we're going to be increasing again, right? Then we've got concavity. It's concave up from 3 to 6, and only that little section. Concave down from -4 over to 3, and from 6 to 7. When I do this, I think about the increasing, decreasing first. And your graphs, like, there's not like one graph that's the correct answer. That's why it says sketch the graph below, but like all of your answers might vary. But as long as you have like everything, whatever you drew matches the given information, then you're right, okay? So there's a lot of different things that could match this criteria. When I do this, I think about the increasing, decreasing first. Because if I'm increasing from -4 to 1, then I'm gonna start with a lower point. Just, I don't know what the y value is, right? But I know that I'm gonna start low because I'm gonna keep going up until 1. I'm increasing until 1. So logically, I'm gonna start a little lower on the graph. Like, you don't wanna start up here and then be increasing and go off the graph. Does that make sense? Okay? So you wanna pick a lower point. Doesn't matter where the y value is that you pick, just pick one. But pick it on the lower end of the spectrum. So I'll go like down here. Okay? I'm increasing until x equals 1. So that means that I need to go to a higher point at x equals 1. I'm going to go a bit higher. So maybe I go to like 1, 3. I have no idea what the y value is. This is just me making a logical guess, educated guess. And then I'm decreasing until 5. So, okay, that doesn't mean I have to go lower than the original spot. It just means that I have to be decreasing. So maybe I go to like here. And then after 5, I'm increasing again until 7. And again, that doesn't mean that I have to go super high. I just have to go higher. It doesn't matter how much higher. It just has to be higher. So pick a spot. Doesn't matter. That's where I start. Okay? Next, the concavity comes into play. What works for me, it doesn't mean you have to do it, but what works for me is I like to draw X's where my concavity is going to change. Okay, so I know I'm going to have some sort of curve, whether it like is concave up or maybe concave down or maybe a combination, right? In between those first 2 points, I like to draw X's where my concavity is going to change. So I'm going to be concave up from 3 to 6. I start off concave down from -4 to 3. So from -4 all the way over to +3, I'm concave down. At 3, I have a change in concavity. I'm assuming that I'm going to connect these 2 dots somewhere around right here at x equals 3. Are you following me on that? So I put an X to maybe be a point on my graph. That's a little bit not right above 3. Let's do better. Okay? Where I think the graphs are going to connect and go there. So from start to 3, I'm concave down. At 3, I change to concave up, and I am concave up until 6. Great, so at 6, probably around right here, I'm going to change concavity again. And then I'm going to be concave down from there, right? I don't really know what happens before -4, and I don't know what happens after 7, but this is what I know. So based on that information, I start off concave down. Okay, concave down and increasing, but then concave down and decreasing, right? Then I switch to concave up from the first X to the second X. So now I'm concave up from first X to second X. After that, I'm concave down again. Okay, so it is possible that they ask you to take that information and kind of go backwards with it. Maybe sometimes giving you the graph saying, where is it this? Where is it up? Where is it down? Where is it increasing? Where is it decreasing? But then also you giving me a graph that matches that information. So taking all that information from the top half of that page and flipping it, and now you draw the graph where it is these things. Okay, again, just asking you to do a little bit of higher level thinking, more than what you're used to from your previous classes. Okay, all right, you're gonna switch to your activity, which looks like this. It's called 2 Truths and a Lie. It's called 2 Truths and a Lie. It's either on Canvas, on the same place where you found your notes, or it's one of the 3 papers you picked up off the table. Okay, but it's called 2 Truths and a Lie. They give you a graph for every problem. 2 of the statements that they give you are true and 1 is false. You're gonna figure out which one's true and which one's false. Yes? Okay, so take a few minutes. You've got 8 of them. So you're gonna figure out on the 8 different problems, which 2 are true, which 1 is false. There's 2 true and 1 false on every problem. Okay? Yeah, just which ones are true, which one's false. I'll give you, and then when you're done, you can either work together or you can like collaborate together. I don't mind y'all chit-chatting while you do this. And when you're done, we'll go over the answers, okay? Give you about 6-7 minutes. Okay? And we'll pause this and then come back. can I pause it or do I have to stop?
Yep.
Okay, we'll just